Okay, so I'm going to show you how to make the formulas for covalent bonds, and we're going to make some dot diagrams. Here we go. We're going to start with this two examples. We are going to make covalent compounds, covalent bonding. So it's not a transfer of electrons now. The whole atom is going to come along with the electrons. So I'm going to be doing this on here. You can do this on paper if you want. I'm going to make a bond between two hydrogen atoms. Those are both nonmetals. I can just drag them from my chemical symbol bank. That's a lot easier than typing it out, isn't it? I know, right? I'm a genius. Well, I'm a genius after the fact. And I'm going to put an electron right next to each of those because a hydrogen has one electron in its valence shell. And in fact, it only has one electron. It is its own valence shell. What we were going to look for is we're going to look for unpaired electrons, and both of these electrons are unpaired. To have a pair, you need two electrons, and I'm going to draw a line representing that these two electrons are going to get paired up, and if they get paired up, it's going to obey the octet rule because hydrogen technically only needs two electrons to be satisfied and stable, right? So I'm going to actually put this electron. The bonded electrons are going to go between the atoms. These are now going to be bonded electrons. I'm using my Control-C, Control-V quite quickly instead of going up and dragging more pictures down because it's quicker, and I like to do that. So now this is a bond. This is a covalent bond between the two hydrogen atoms. They are sharing those electrons, and they're now nice and stable. Now, I can represent those bonded electrons with just a line. And I'm going to actually copy and paste this entire thing. I'm going to unselect the H's and delete the dots, and then I'm going to drag a bond down so it's between them. And that's the line structure. I can just show the line structure like that. Now, how many atoms of hydrogen are in this compound, or in this molecule? It's not really a compound. This is a molecule of an atom, an element, so it's an elemental molecule. And I'm going to use a subscript again and make it 2. This is H2. This is one of the diatomic elements. There are 7 of them, and I will talk about those later on and tell you exactly which ones they are because you have to memorize them. Now let's do a little more complicated example. All right, we're going to go to the next example. And we're going to have 2 atoms of carbon, 3 atoms of hydrogen, and 1 atom of fluorine. Now, I noticed that when I did this, there was way too many. It was too large. These things were too large. I'm going to put the 2 atoms of carbon like this. Actually, you know what? Because there's 2 atoms of carbon, 3 of hydrogen, I'm going to do this. I'm going to show you a little trick. But these are kind of large to fit in this space. What you can do is highlight them and reduce them. Now it's not going to keep the aspect ratio when you do this in this particular program, but you can kind of make sure they look kind of good, and then you can drag them around. Now carbon, it has 1, 2, these might be a little big here, 3, 4 electrons around it, right? Okay, and they're all unpaired. But I need 2 atoms of carbon, and so I'm going to highlight the whole thing, copy, paste, and I'm using the arrow so I don't accidentally just grab one part of that, and I'm going to put it like that, okay? And then I'm going to get an electron from my hydrogen, and I'm going to put it right next to it, and I'm going to highlight that. I'm going to copy and paste and use my arrow key again, and paste another one. Using my arrow key. It doesn't matter, they don't have to be in order, just make sure you know where they are. Okay, my fluorine is going to have 7 valence electrons around it. I'm going to actually steal carbons and use them to get 4 of them, so I don't have to drag a lot. I'm going to be smart about this here. And then I'm just going to drag the rest 4, or 3 I mean, down to where I need them. These actually are slightly large, and they don't really show the sides very nicely, so we're going to just move them around like that. Okay, so if you notice, we've got, on fluorine, we have 3 pairs of electrons on 3 sides. and one unpaired. This is the only one that can actually take place in a covalent bond. What we have to do is we have to think about each of these little spots, each one that has one unpaired electron. That's where a bond can happen. And it's going to bond with another electron that's unpaired in another atom. For example, this electron right here can be bonded to this one right here because they're both unpaired. I could not say this electron and this electron can be bonded because this electron is already paired with that one. So we cannot do that. All right, so this is a kind of a puzzle. We have to bond every single unpaired electron with another unpaired electron. We can also realize that we cannot bond a hydrogen atom to another hydrogen atom because then these are used up and they won't be attached to anything else. So it is a puzzle. I am using this curved connector, and the way you use that is you click once each time to make it curved, and then when you're ready to click it at the end, you double click it and it will finalize that for you. So all my unpaired electrons are now paired. Now it looks kind of messy. You kind of have to look at it a little carefully. Between the carbon atoms, I have two pairs of electrons that are shared now. Okay, so I'm going to actually put them in the center. Carbon often goes in the center. So the two pairs go in the center like this. These four are part of that bond. That makes what we call a double bond. Now we're going to have hydrogen went over to this side. So that comes like that. So that's this group right here. It goes over there and attaches right there. And then that one comes right there. You can see this one right there. It goes over there to that carbon like that. And then this hydrogen is going to go underneath the carbon, the second carbon. So I'm going to bring that over there. And then finally, my fluorine is going to attach right to that last spot. There's my compound. Looks amazing, doesn't it? Now we got to do the structural compound with the lines. I'm going to copy and paste that whole thing. Now, I want to get rid of all the valence electrons. And so I've got all of this highlighted. The easiest way to do this is hold the control button down and click on the center of each symbol. So now they're not highlighted. Now just the valence electrons are highlighted. I'm going to click delete. Look at that. It's amazing. And I'm going to now drag some bonds down. And because there's two pairs, there are 4 electrons between the carbons. That's going to be a double bond like that. And between the fluorine and the carbon, there's 1. Between this hydrogen and carbon, there's 1. There we go. Voila. Look at that. Now, in our chemical formula, in this we have 2 carbon, we have 3 hydrogen, and 1 fluorine. And that is the chemical formula for our compound.